Okay, what we're going to talk about here is transition metals. We've talked about polyatomics that go along with those ionic compounds, and here we're going to talk about transition metals. So if you're not sure where those transition metals are, look in groups 3 through 12 on your periodic table. It should be that very middle part that looks like it's dropped down. So transition metals, they'll bond with those nonmetals and with polyatomic anions to form ionic compounds, okay? Unlike the other main group elements, so that's 1A through 8A, or we like to say those as group 1, 2, 13 through 18, transition metals can have more than one ion charge. So we can't just look at the periodic table and say, hey, this is in group 1, so it has a +1 charge. It's going to give up that 1 electron. So that's why we get a +1 charge. So it doesn't work out that way. The rule of zero charge is something that will help us figure out the charge on the transition metal ions. And we're going to look at how paints normally have different metals in them, specifically transition metals, and that's how they gain their colors. Okay, some learning goals here. We're going to be able to recognize transition metal compounds and their names. We're also going to be able to determine the charges on transition metals by being given their chemical formula and looking at what they're forming compounds with, okay? So we're going to work with uncrossing charges to figure out what charges are on transition metals in ionic compounds. Okay, so if you take a look here, these transition metals bond with nonmetals and those polyatomics to form ionic compounds. So take a look here. You see at the very bottom here the names of transition metals, and you also see charges listed in those test tubes as well as different colors. Okay, so these are just different colors that transition metals can produce based on their charges. Okay, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper. A few of these you saw in your flame tests, specifically copper, nickel, and cobalt. But if you take a look at these other ones, they produce different flame colors based on whatever their charge may be. So if we would go back and reflame compounds that had these transition metals with all of these different charges, we would be able to see these different colors. Okay, so if we look at these transition metals, again, we can say they have different charges, more than one charge. Some of them can be present with 3 different charges. Let's look for iron on your periodic table. Iron has an atomic number of 26. For example, okay, the 2 most common charges for iron are iron with a +2 charge and iron with a +3 charge. Okay, when we write the names for these irons, we're going to use something called the stock system. Okay, and the stock system gives us these great Roman numerals. Okay, and if you don't remember Roman numerals, it looks like a capital I represents 1, II is 2, 3 I's represents 3, and IV is 4 because V is 5. Okay, and we're not going to have anything with the charge of +5. Okay, but if we look at these and we have iron with a +2 charge, if I need to write iron with a +2 charge as my metal, I would write iron 2 and then whatever my nonmetal is. Okay, if I need to write out the name of iron 3 in a as a name for a compound, I would write iron 3 and then whatever the nonmetal is. Okay, and we only have to use those Roman numerals when we are writing out the names of the transition metals. Okay. All right. The rule of zero charge can help you figure out the charge on that transition metal ion. So if the charge is not given directly, you have to figure out what it is. Okay. We're going to do some examples here, and that should really help us out in understanding these. We're going to do a lot of practice with this. Okay. We are starting out with ions. We're going to come up with the names of the ions. They will be placed in an ionic compound, and we're also going to name the compound, okay? And so we're going to have to go back and forth and do some different things here, okay? This says we have Fe plus 2, okay? Well, how do we write out the name of this ion? This would be iron 2 as an ion, Okay, iron 2, where does that 2 come from? That's the charge. Okay, if we look at the name of the compound, it says that we have iron 2 oxide. Iron 2 oxide. So we have to come up with that formula. We know that iron 2 is represented right here, or this is the actual formula for that ion. Oxide comes from oxygen. So let me write this out because we learned about crossing the charges. I have Fe plus 2, and I have oxide, which is oxygen. Look for oxygen on your periodic table. Oxygen should have a -2 charge. Okay, so when you cross your charges over, that should simply give you a formula of as FeO. FeO. Okay. Here we're going to do it a little bit backwards. We're telling us that the name of the ion is iron 3. So I'm going to write the symbol for iron, Fe, and I'm going to give it a +3 charge. Okay, that's pretty simple. Okay. The ionic compound is listed as FeCl3. Just to make sure that my charges are correct, I want to uncross these charges. And this tells me that I have iron with a +3 charge and chlorine with a -1 charge. Okay, so that's correct because it tells me that my transition metal does have a +3 charge. Okay, and chlorine, if we look at the periodic table, does have a -1 charge. So if I want to name this, I'm going to call this iron 3 chloride. Okay, iron 3 chloride. Okay, same thing here. It says we have a copper 1 ion. So the formula or the chemical symbol that we're going to represent this transition metal with is going to be Cu with a +1 charge. It tells me here that my formula for my ionic compound is CuF. Let me uncross my charges just to do some checking. Cu with a +1 charge, F with a -1 charge. Great. Capital F is representing fluorine. And so as we name, we chop off the ending at IDE. We would have copper 1 fluoride. Okay. We're going back down here, and we are seeing that we have Pb with a +4 charge. So Pb, if you look on your periodic table, this is lead. Okay. It says I have a +4 charge, so in parentheses, I have to list my charge. The name of my compound is lead 4 iodide. So that means I'm forming a compound with lead that has a +4 charge and iodine, which has a -1 charge if you look for it on your periodic table. Okay, so take a look. I have Pb with a +4 charge and iodine with a -1 charge. To get my correct formula, I have to cross my charges over. This gives me PbI4. Okay? Many of the paint pigments that artists historically used and continue to use have those ionic metal to non-metal compounds. Okay, again, just another representation of how they color these different glass bottles. So let's do some practice.